Good morning, welcome back. This is Advent of Code Day 17. Quite a tricky problem yesterday, and I must confess that I did not solve part 2 on SCAMP. I wrote the program on SCAMP and set it running, but it was going to take too long, so I ported it to Zig, ran it on my Linux computer. It took 2 minutes, which I estimate would scale to about 4 years on SCAMP. Oh, my webcam isn't working. Stand by. Boop boop. Okay, good. Anyway, yeah, yesterday's problem being so hard is why so many people on the leaderboard have not done part 2. So hoping for an easier one today. Maybe make up some ground on Harry Freeborough. Right, good luck everyone. Oh no. That hasn't worked. Maybe I will restart the Advent of Code proxy. This isn't a good sign, is it? Okay. Falling rocks. This doesn't look easy at all. Your handheld device has located an alternative exit from the cave for you and the elephants. The ground is rumbling almost continuously now, but the strange valves bought you some time. It's definitely getting warmer in here though. The tunnels eventually open into a very tall, narrow chamber. Large, oddly shaped rocks are falling into the chamber from above, presumably due to all the rumbling. If you can't work out where the rocks will fall next, you might be crushed. The 5 types of rocks have the following peculiar shapes, where hash is rock and dot is empty space. Okay. The rocks fall in the order shown above. First the minus, then the plus, so on. Once the end of the list is reached, the same order repeats. The rocks don't spin, but they do get pushed around by jets of hot gas coming out of the walls themselves. A quick scan reveals the effect the jets of hot gas will have on the rocks as they fall. For example, suppose this was the jet pattern in your cave. Push to the left, push to the right. Jets will push a falling rock right, then right, then right. Yeah, fine. If the end of the list is reached, it repeats. The tall vertical chamber is exactly 7 units wide. Each rock appears so that its left edge is 2 units away from the left wall, and its bottom edge is 3 units above the highest rock in the room, or the floor if there isn't one. After a rock appears, it alternates between being pushed by a jet of hot gas 1 unit and then falling 1 unit down. If any movement would cause any part of the rock to move into the walls, floor, or a stopped rock, the movement instead does not occur. If a downward movement would have caused a falling rock to move into the floor or an already fallen rock, the falling rock stops where it is, having landed on something, and new rock immediately begins falling. Okay. Sounds broadly straightforward. To prove to the elephants your simulation is accurate, they want to know how tall the tower will get after 2022 rocks have stopped. Okay. So we've got 7 wide, 2022 rocks, and the highest rock was 3 tall, I think. So let's call it 7 by 6,000. What do the rocks themselves look like? And more specifically, how are they represented? The tallest rock is 4. So we could make each rock be a 4x4 bitmap. A 4x4 bitmap is a machine word. Maybe that's overcomplicating it. Maybe we just make it a 4x4 array. So they never rotate. And then we can fill them in by doing, we say 0, 0 is the bottom left for the 4x4 area. So we want 0, 0, 1, 0, 2, 0, 3, 0 for the first rock. 1, 0, 0, 1, 1, 1, 2, 1, 1, 2. I'm likely to want lots of variables called rock, aren't I? So we'll call this rock. Oh, this is silly. I already have a way to do this. Rocks I, and then these are XY. Maybe this should have been YX. Oh wow, the map is XY as well. Rocks I, B0, B1 equals 1. So this isn't line, this is jets. Okay. Rocks start at x equals 2, y equals y plus 3, if I recall correctly. Yeah, so not min y, it's max y. And what does the question want to know? How tall the tower is. Yep. And what rock type do we have? Well, given rock, the given xy coordinate does not collide with the map. What order does the jets happen in? Does it slide and then fall? It slides and then falls. Oops. Okay, get the new x coordinate. If it would hit, well, this is an easier test, isn't it? this. So we have to know the width of the rock. If it's 1 wide, 1, 2, 3, 4, 5, 6, then it's allowed to be at 6. Okay, so that slides us left and right. That's not enough because the slide can also cause us to collide with the actual rocks. Max Y, well, so you do want the rock height as well. Great, so we need collide and paint. Paint is easiest. What we need to do is VM set map x is px, y is py, 1. Collide, well, the rock collides, very similar function. The rock collides if any point on where we would paint the rock is already set. Maybe it would be neater if these two were the same loop with a callback, but this will be fine. So if bm set map x plus px, y plus py, and when it does collide, none of the points collide, it does not collide. So actually, our rock representation is suboptimal. We actually just want this representation. Yeah, because my function forgot to test whether the tile was actually set in the rock. So this all wants to go away. Okay, good. That's better. Now, that may be a complete solution. And I think it should be reasonably fast. It doesn't obviously do any unnecessary work. We should have made it print progress information. Okay. That could be because I made a typo. I could store the jets as a bitmap. I don't think that would be necessary. I think just compile it would be enough. So if this looks like it's going to complete quite quickly, I will just run it and see if it gives the right answer, and if so, run it on the real input. If it looks like it's going to be quite slow, I wonder whether... Well, what I could do is make it print max y at each step and compare that to the sample output. Maybe I should have done that already. I could reduce the bounds on the allocations so that we can run it in the interpreter for the sample input. That's not good. So after the first dot, the computer resets. But why? Normally that means the wrong number of arguments has been passed to a function. Yep. Oh, hang on. That should be... Okay, that's that. Now, the other thing was... Oh, let's stay as that. Okay, that obviously hasn't worked. I need to stop the rock when it hits the floor. So collide is true if any of those. Still bad. Oh, I forgot to set x equals mu x. Silly. Also, I painted it in the wrong square. Oh no, that was correct. However, it still didn't work. Oh, y needs to get smaller, not bigger. One, 4, 8, 10, 11, 14. Yeah, 1 is correct. Eight isn't correct. I've missed out a type of rock. After the plus, we've got an L shape. Okay. After the plus, we said. Oops. We're not really using rock W and rock H, are we, anymore? Never mind. Oh, this one is. So it should be 1, 4, and then 6. Yeah, so the problem is my max Y is off by 1. Well, max Y is the smallest Y coordinate that does not contain any rock in my program, because it starts out at 0. Yeah, so we start out at 3, and we start out at 2. Maybe I need to be drawing the map. That's not right. Did I forget X plus plus? We didn't paint the very first one. Oh, I'm just not drawing the bottom row of the map. Yeah, so this isn't working properly. Because right, so and then that one goes directly on top. Should I not be resetting the jet pos for each one? Yeah, so the first one lands in the right place, but that would also happen if the jets weren't pushing the rock at all. The second one doesn't land in the right place. Yeah, okay, well, I don't think I should be resetting jet pos. Otherwise all the rocks end up in the same place, don't they? That's not right either. Jet pos needs to start at 0. Okay, so the first one's right now. Yeah, this is right now. 1, 4, 6, 7, 9. 6, 7, 9. Good. Let's see what it says the answer is. Do we even need to confirm it on the sample input? Because I think I've confirmed that it's working correctly anyway. So maybe I go straight for the real input. I'm going to do that. And if we're doing about 2,000 rocks, it will be slightly less than one entire screen full of dots. Oh no, a screen full is 2,000, isn't it? Yeah, it'll be slightly more than one screen full of dots. And what do we think part 2 could be? If part 2 is eliminate completed lines, how would we do that? Maybe we just have to do it the slow way. If we have to do that, we could look inside the bitmap library to remember how the cells are laid out, and then work out how to get memcopy to shift all the lines around. Although I don't know if my memcopy is happy with overlapping regions. Can't remember. Okay, let's see what we got. Yes. 2755 isn't bad. Wow, okay. Well, we have 10,091 jets. We've got 5 rocks. 10,091 times 5 is 50,455. And I'm saying that every 50,455 rocks, the tower is the same. Can we do any better than that? Because simulating 50,000 rocks is going to take 25 times as long as part 1 did. Maybe let's can the height be a big int? I'm going to say it can be, because in part 1 the tower was 1.5 times. The tower grew by 1.5 for every rock that we dropped. Because the answer was about 3,000 and we did about 2,000 drops. That's really annoying. It's just slightly out of what we can do with 16 bits. And I can't index my bitmap with big ints either. Can I even store a map that big? Well, if it's 1.5, if it's 75,000 by 7, then the map takes up half of my memory, which might be okay. Actually, it won't be, because, well, I could switch to using bitmap for the jets. There's just barely enough memory, I reckon, but addressing it is complicated. I wonder how we're looking on the leaderboard. So Ictrobot's done both parts. Nobody else has done either part. So that's good. I gained some points on Harry Freeburg at least. But how am I going to do part 2? Is there a trick to it? Maybe we look at factors of that big number. What's the easiest way to factorize things? Do I have a program that finds factors? Feels like the sort of thing I might have written for fun. No, can't see one. Well, we can look if that number is divisible by what I said. 142857. Isn't that the digits of 1/7? That's very suspicious. 142857, 142. Those are exactly the digits of 1/7. Maybe then. Well, let's look at this first. Is that an integer? No, not exactly. So it's not the thing I said about... Oh, it might be. Oh, yeah. But... well, what if the trick is that the answer is always the same? That would be a bit stupid, wouldn't it? Okay, so why... I don't accept that having 1, 2, 3, 4, 5, 6, 7, 8, 10 digits in a row match the digits of 1/7 is a coincidence. Oh, it's grown by 1.5 plus 1/7. Maybe I just need to calculate that value for my own input. Well, what was the... $3,068. Or is it 1.5 plus 1/70th? Yeah, it's growing at 1.5 plus 1/70th for the sample input. But how do we work that out? And what was my answer? I can cheat and look at my Linux computer. I'm going to do that because the output from my thing, it was 3197. The output from my Advent of Code proxy tells me what it was. So the first part of the problem doesn't have enough rocks to work out what the growth factor is. However, what if we did 10,000 steps instead of 2,000? What if we did 10,091? Maybe this only works on the sample input because the number of jets is so small. Maybe I'm completely barking up the wrong tree. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 40 characters there. So the sample input should repeat every every 40. Except they can fall below the floor. That's the problem. Yes, so it's not as simple as that. However, I think the fact that the sample input grows at a rate of 53/35 suggests that the real input might also have a rational growth rate. Or does it? Maybe it's just the fact that the sample input is so short. Okay. We're going to try a growth rate of 79/50. How many rocks is it? It's probably not right, is it? Because it's suspiciously round. Are there any other sensible rationals that work out to around 3197? The denominator of 53/35 is 7 by 5, which is the number of rocks times the width of the thing. Doesn't necessarily seem like it's relevant. Maybe the only reason the sample input has such a neat answer is because it's so short. Okay, I'll try one more. Seems unlikely. Too high. Why didn't it tell me the other one was too high? Alright, that's enough numerology for now. I'm going to stop, read the subreddit, maybe have another think about it. Alright, see you in a bit.